the authors introduced a new term here. It's called the Campus Area Network, or CAN. This is a network spanning multiple buildings on the campus. So, think of it as a college campus, multiple buildings out there, they're all connected via network, and campus area network. So what are some of the items we have to consider when building our network? A lot of it has to do with the devices on our network and what our network is being used for, so our network needs. The types of devices, workstations, servers, printers, phones, IoT devices. What's going to be on your, what do you have to support? The types of devices determine if you're going to need a wireless network, a large wired network, what kind of switches, routers, and to degree security. What's your environment look like? What's your building made of? Do you have access to walls? Can you put new jacks in? Do you have drop ceilings? Do you have solid ceilings? A lot of glass in the building? Is it a dirty or clean environment? Is it wet, dry? What's the temperature like? That's going to all play into some of the equipment you have to buy. What's your existing cable plant look like? Do you have patch panels? Is it properly terminated? Is it Cat 3 or Cat 5? Have they terminated the stuff properly? A lot of this, all that we've talked about, is going to lead up to compatibility with equipment. So right here, wireless, compatibility, etc. This all depends on what your answers up here. What's your internet connection look like? Is the performance, latency, do you have enough bandwidth available? And what are your security requirements? A lot of these terms we haven't seen before. HIPAA and PCI we haven't really talked about, but those are security requirements. Payment card industry is for credit cards, that's PCI, and HIPAA is your federal protections for medical information. Further into your needs, how many offices are in your buildings? How are the offices laid out? Do the offices have existing network cabling in there? And what type of cabling is it? If you walk into an older office and they got coaxial cable, that's not going to help you in today's environment. Do you have a computer room or an IDF, an MDF? Is it large enough to hold your servers that you need to install? Is it enough power to hold your all your equipment, servers, routers, switches, firewalls? What's the overall requirement for your internet, for your bandwidth? And this wireless coverage needed. And this wireless coverage needed indoors and outdoors, above ground, below ground. What kind of temperature and environmental conditions do you going to run into? What's your power availability, especially in your data center? Is that going to, some of these servers need 220 volts. And you might get into some areas where you've got 48 volts DC. You don't have AC. So can you get equipment that will run in those environments? So what kind of documentation and why do we document? Prior to we want to document so we can just get an idea what we have out there. Documentation is important in a couple of different areas. One area and documentation is important is just maintenance. You gotta know what you have in your walls. For the cabling, I can't tell you the number of times I've walked into an office and I ask people what's in that wall, and they say, and today, everyone's gonna tell you Cat 5. I don't know why we haven't used Cat 5 in years, but it's just Cat 5 cable. And I look at them point blank and say, if it's Cat 5 cable, we got to pull it all out, because you're asking for gig connections, and with stuff we're going to be pushing through here, especially in our data center, at 10 gig, Cat 5 is not going to cut it. So we're going to pull it all out. And they all kind of just look at me. What do you mean? I go, Cat 5 only supports 100 meg. Remember that back in our wiring discussion. Cat 5 supports 100 meg Ethernet, does not support 1 gig Ethernet. You need 5E for 1 gig. So if you got to know what you have. You want that documented because sure enough, 10 years from now, someone's going to come and ask you what you have, and if you want to give them the right answer. Uh, you want it when you build it out, and you want it when it's finished. So you want your build out, so where the jacks are. If you have J boxes, you want those documented. You want how the cables run. You want to know roughly where your equipment's located. Licenses. You want to know where your licenses are for your software. Uh, we're in an environment today where um, we actually buy a router or a switch and it's got licenses on it, software which you're able to run on it. So keep that in mind. It's not the old days where you just bought a 48 port switch and it just ran. We're not in those environments anymore. VLANs and IP addresses. What VLANs are out there? What IP addresses are out there? Who do they support? Know your IP address utilization. Always plan for growth. Always plan for growth. You can go out there and say, hey, there's only going to be 5 people in that office. So you put together a really strict network address. You're going to account for 8 devices. And sure enough, what ends up happening, sure, it's only 3 or 4 people. And then they get a printer, wireless access point, an electronic time card, clock. Oh, that thermostat, that's now connected to your network now. Pretty soon you're out of IP addresses. So plan for that growth. Find a place to store your vendor documentation. A lot of this electronic. Just find some place to store it where everyone can get to it. Know your standard operating procedures. Know your configurations. So this is not just SOPs. This is also configurations. This is configs. Where are they? To get to them. Just an electronic place to get to them. There's a bunch of software products you can buy that will store these, but at this point, you're just looking at keeping these things in a common place where you and your team can find them. So your network design should account for workstations, servers, equipment room, and peripherals. To kind of discuss this. For your workstations, you want your total number, where they're located. And when I say distribution, it's not uncommon for, say, an accounting and finance group to have a large concentrations of workstations, printers in one relatively small area, where, say, an engineering company or an engineering group might have a staff that's more spread out. So just keep that in mind. You want to know the distribution. That'll help you with your IP addressing, also the type of switches you're going to have to buy. What are connectivity requirements? Again, this goes back to the number of laptops and desktops. These laptops are mobile. People take them into conference rooms. You don't want to take them into a conference room and find a jack to plug into. That's your wireless requirements. Do you have a campus with different buildings? And do they want coverage when they're outside the buildings on these walkways? So someone's walking from this building to this building, do they want to have coverage for the laptop? Keep that in mind. For your servers, you want to know how many physical servers and the number of virtual servers you have. Again, that's more for IP addressing than anything else. But for the physical servers, we have power and network to deal with. For the virtual servers, it's more of a situation where it's IP addressing and security. What OS is running each server, you have to have that. You cannot, do not skip this. Know what OSs are running. These OSs expire. They are ceased to be functioned. You can't get patches for them. You have to know what OS you're running so you can swap them out before that happens. And don't think, oh, I'm just going to, I've got a 5-year plan. Every 5 years we're going to swap out servers. That's not going to happen. As much as you try, you're going to be short a few dollars one year and say, oh, that server can run another couple of years. Well, then all of a sudden, now that server's not patched because you can't get patches for it. How do people authenticate to these servers? Is it Active Directory? Is it Radius? Is it TACX? Say, are you running 802.1x to authenticate your devices? Know how you authenticate. How is logging done? Do you have a central logging server? Or log stored locally? Does the organization require production, development, and test on their servers? Um, you know, we like to laugh. I like to say where I work, we have one server per person, and that's because we have a number of applications out there, and those applications, we have a test, a development, and a production. So for each server, for each application, I've got a minimum of 3 servers. And where does that feed into? Power and networking and IP addresses, along with security. So keep that in mind. You need to know what you got out there. From a security standpoint, just think of this little axiom for security. If you don't know you have it, you can't defend it. Where is your equipment room located? Center of the building, off the edge, just get to know where it is. Because you have to get cable to it. And that's where your servers are, so you got to get cable from those servers out to the workstations. What are your physical servers needed? Again, that's more for power. Environmental conditions of the server room. This is not the 50s and 60s where you have to keep these things frigid. They're not going to keep them in the 50s. You can keep them comfortably. They can be at 70 degrees, 73 degrees, and they will operate just fine. But you need to know what your conditions are. What's your availability of power, voltage? How many outlets do you have? UPSs, generators. That knowing all that helps. Your peripherals. How many are there? What type are there? Where are they located? Document their power requirements if you need PO power over Ethernet. What are their connectivity requirements? Can they use wireless, wired? Believe it or not, I still run into things every so often. It's rare now, but I ran into one last year where someone handed me a device and it required half duplex 10 megabit. And we didn't have it very long. It met a whole bunch of other had a whole bunch of other flaws in there. It was like, but you need to know that stuff. Your compatibility for cabling. You know, if someone walks in there and you got a building and they say it's Cat 5e all over the place, that's probably going to be good enough, unless you're going to a server room. But 5e is probably going to be good enough for workstations. 6 definitely will be good enough. In a server room, you want 6 or 6A, but you'll want to know what kind of cable's out there. What type of cable is needed? Again, if we're on a campus area network and I got different buildings, and what distance are they? Is it relatively short walks? Under 20 or 30 meters. You can consider pulling copper cable. But keep in mind, if it's outdoors, you've got things like lightning and water you have to deal with. So keep this stuff in mind. Do you have UTP or do you need shielded twisted pair in some cases, especially if you can run this stuff outdoors? If you're running fiber optic, what kind of distance are we looking at? Do you need multi-mode or single mode? What are your conditions? Do you allow to have EMI? You're going to run this cable under a road. Believe it or not, if your cable's not buried deep enough, that vibrations and stuff can really wreak havoc on copper. What kind of standards are you using? What are your wireless requirements? Do you have requirements to put wireless outdoors? Can you get along with N or AC? Do you have a 2.4 or 5 gig network? Your VLANs. That's another thing you want to deal with. How do you want to assign these? Is your wireless going to be in separate VLANs? Or are they going to have share a VLAN with a wired network? So that'll lead to your IP address scheme. Your internet connectivity requirements. Do you host your own DNS, or does someone do that for you? How about routing? Do you have to put BGP out there, or can you do it with a static address? What's your border security look like? IPS, IDSs, firewalls? What kind of cloud services do you have? A lot of companies are taking email to the cloud. A lot of services are in cloud-based. Hey, how many of us have Gmail accounts? You can go to Google, and that Gmail account, they'll spin that up for a corporate environment. Under unified communications, use your VoIP systems, so your IP telephony. What kind of gateways do you need? Do you have a traditional PBX you're dealing with? What kind of VoIP protocols are you using? And these lead into what kind of quality service are you running? What are your fax, video, messaging? Do you want your voicemail to be tied into your email system? Do you have a collaboration system like Microsoft Teams or some other product? What kind of voicemail? To get out to the PSTN using SIP or ISDN. Both of them are viable. SIP is probably the more prevalent today for new installations, but there's still a lot of ISDN out there. So remember, when we're talking networking, we're talking, what do you support? So that takes us to our industrial control systems. Industrial control systems monitor processes in an industrial or utility setting. These are systems that are really designed to run for 10, 15 years, decades. They're in harsh conditions. This stuff is really built to last. This is not the typical IT stuff you swap out every 4 or 5 years. This stuff it's built to last 15, 20 years. So keep that in mind. What do? They monitor things like temperature, power levels, illumination, mass. They have automated processes to control heating and voltage and pumps, valves, roofs. Distributed control systems. These are made up of these are a type of industrial control system. They have, this is what we call the human-machine interface. So they have sensors that monitor something, an automated controller. This automated controller here is a machine. It's not a person. It will go out and it knows what to do. It's been programmed to, make sure so much chemicals are added to water in a given hour. Then the operator, this is a person. So this operator here, that is a person. So they're sitting there and they're monitoring the controller and the sensor, and if they have to make adjustments, they will. They call this the human-machine interface. A PLC, or programmable logic controller, is a computer that controls a machine, and they are programmed. Someone they follow specific steps. For example, they may add a chemical, stir the pot, heat to 185, cook for an hour, and then monitor that whole process. Your supervisory control and data acquisition, or SCADA systems. This is a lot like a DCS, but it's on a lot larger scale. We're talking, this is what power companies use, what water utilities use a lot. These span they can span hundreds of miles. So it's very, very automated. It's a very, very automated processes. You're going to find a lot of PLCs in a system like that, and they're really designed to operate unattended. So one thing we want to talk about is the segmentation of your SCADA and your IT systems. Typically, they don't touch each other. So a lot of times you'll have is a SCADA network here. Then you're going to have some kind of a firewall here, and then you're going to have your IT systems. On the SCADA network, we do not want that touching the internet, And we really don't want it even touching the IT systems, but there are some processes that might be running over here that have to send data this way. And in reality, rather than send data this way, we'd prefer the SCADA machines reach out and pull the data. But we actually segment those. We never run SCADA and IT together if we can help it. That's it for Chapter 17. I'll have Chapter 18 out there pretty soon.